Hello and welcome to the first part of our car rigging tutorial. You see here our car model. This is a preview model I quickly put together and it'll serve the purpose. First of all, you have to make sure your car body is one part and that all your wheels are separate parts as well. Also make sure that the pivots of your wheels are nicely aligned to their Y and their Z and X center, so the rotation can happen correctly. I've also made sure that all our geometry meshes are on one layer so we can easily hide and show them. We're going to start off by creating a new layer, which is our rig layer, and this will be our default layer. Note the checkbox which is marked next to the name. Okay, we're going to be building lots of components for this rig, and most of the time I will be using a dummy for that. So dummy can be found under helpers. We click dummy and drag to create one. What we'll be doing all the time is renaming our rig components so they can be easily found and tracked when you work with them. This dummy will be called dummy wheel hub front left, for the front left wheel. Once we've created that, we click the align tool, which we will be using a lot also, and then we click the front left wheel. Notice that when using the align tool you can align position, orientation and scale. Position is the one we will use extensively, the orientation pretty much never. You can choose what to align, X, Y and Z position, disable them and enable them at your will, and you can choose to align by center or by pivot. For these wheels we want to enable center for the target object. See, so the dummy is nicely in the center of the wheel. Once we've aligned this part, we duplicate it, always copies, and it will be dummy wheel hub rear left. Align again. OK. Duplicate this one again. This will be rear right. Align it to the wheel again. One more duplicate, and this one will be front right. OK. And align it. There we go. We've now aligned our dummies to our wheel positions, which are pretty much the most important positions in our rig. What we can do now is just hide the rig, hide the mesh, since we won't be needing it any longer for the moment. Okay, so now we have our 4 wheel positions. These are not enough to get started. Notice how I've called them wheel hub. These aren't exactly our wheels. We're going to start by creating components for the steering first. I create another dummy, making sure it's slightly larger than the existing ones, aligning it, and I will call this dummy steering hub front left. I will duplicate this one and I will call it steering hub front right. Align it. And now we need to create the actual wheel dummies. Align this one to the front and call it dummy wheel front left. OK. Repeat the same action all over. Rear left. Rear right. And front right. Okay, what we will be doing now is linking these components together. We will link the wheels to the wheel hub, and on the front axle we want to link them to the steering hub and the steering hub to the wheel hub. Oops, done that one wrong. Just repeat the action and zoom in to make it easier. To the steering hub and steering hub to the wheel hub. Now these wheel hubs will be moving up and down as suspension. And you can see their children are moving along because they are linked to it. Same here, 3 children move along. Now what these steering hubs will do is they will rotate left and right for the steering. The actual wheel dummies will rotate along their y-axis to simulate wheel rotation. Right, so we've built these components. It's time to start building the suspension for our car. It's actually one of the hardest parts to build. We're going to need some more components for that. Create this small one and align it to the rear axle. Put this one to pivot point just to make sure. Now we will be moving it up. Doesn't matter how much, just an estimate. Something like this. This is actually the point where your suspension will be anchored to the body. We'll call this one dummy susp anchor for suspension anchor, rear left. Duplicate it, call it rear right, align it to this one, and notice how it jumped down. You can disable Z position so it stays on its original height. Want to duplicate that again to front right, align. It remembers your disabling of the Z position. Duplicate it again, and this one will be front left, like we've been doing all the time. Okay, so now you've created these suspension anchors. We want to enable functionality on them. So what we need for that is some sort of way where you move the wheel hub up and down, and the suspension anchor will respond to this movement like it is connected by a spring. So if you know how a spring works, slight movements will not affect the suspension anchor, but big movements will affect it a lot more. That's why we need to build a special function. You can't just link them together. As these objects only move up and down, we'll be creating paths and constraining both objects to a path to make the process of linking their movement together more easy. We're going to start off by going to splines, clicking line, go in side view and create a line like this. Okay, now to make things easier, we see the position of this object is 41.426. We're going to change this into 40 just to make our life easier. You can actually select all objects at the same time and type in 40 to move all of them to that 40 position. Now we have this line here, which we will align to our first suspension anchor. Also enable Z position. This line is the line along which the suspension anchor will be moving. Well, note that this line is the actual travel our body will be allowed to do. We might want to make this a little shorter since we're working with a sports car here that has little suspension travel. The way we do this is just go into the splines vertex mode, select a vertex, and let's say we only want to give it a travel of 20 in every direction, so we need to type in 60 and 20 at the bottom. There we go. Okay, we're going to call this line susp anchor limit. Make sure to use capitals all the time. Now let's just call it susp anchor rear left instead, just to make sure which one it is. Okay, so we've created this one. What we will be doing now is constraining this dummy to this path so it can only move along this line. To do that, we need to go to the animation menu, constraints, click path constraint, and then select the path. You'll notice how the object has jumped to the top or the bottom. It depends on in which order you drew the points of your line. And if you move the animation slider, you will see it's automatically been animated along that line. We don't want any animation in our rig, so we will select every key and delete it. Now we still want to move our dummy to the center of our path again. So notice how the motion tab with a little rotating wheel has opened and how it is set to the position list mode. You can scroll down and then you will notice there is a path parameter tab here that has a percentage along path slider. So at 100% we want to change that back to 50. You will see our path is back at our original 40 position. Right, so once that is done, you will notice that you cannot move your path on X and Y anymore. It's stuck to moving over its Z axis. Right, so we want to do the same thing with the wheel. Only enable it to travel, the wheel hub, only enable it to travel over its Z axis. You can still move the path, but the dummy can't move by itself. So to do that, we will duplicate this line, copy, we'll call it line wheel travel rear left. Align it to the wheel hub, there you go, and change the color to something obviously different from the other color. We've got a green and a brown one now, which is a nice difference. We're going to do the same thing, select the wheel hub, animation, constraints, path constraint, and click the new green path. Thing has jumped up again, we need to fix that. Delete the key, go to the percentage along path, set it to 50, there we go. Right, now we want our susp anchor to move when we move our wheel hub. We're going to use something special for this. We select the susp anchor. We're still in the motion tab. This is open by itself. We need to use this a lot. There's an assign controller list here that has a list of all controllers which are available parameters of an object, and you can see there's, apart from position, there's a path constraint controller on top of that, just like you see in this list here. You can fold open the path constraint and you see the percentage along path is a linear float in that list. The linear float is the type of controller. We can actually change that by clicking this assign controller button. What we need is a float expression, because an expression can be used to formulate a special type of connection between several controllers. Click float expression, click OK, and then we get this big scary window. There's actually not much to this window. There's the actual expression, a description, which doesn't matter. It's only for documentation purposes. There's a create variables interface, which we will use now. P1 is the name of our first and only variable. Using this short name because it makes things easier. We click create and it appears in this list of scalars. We'll only need scalars. Vectors are multi-variable parameters. We won't need those. You see there are two buttons here, assign to constant, assign to controller. A controller is an object, a parameter from another object. In this case, the percentage along path of our wheel hub. We want to link these together, so we click P1, click assign to controller, and you see we get a very big list of all our controllers in the world. If we fold open objects, we see we have all our created objects so far here. We need our dummy wheel hub rear left. Fold this one open, transform, position, and you see that path constraint is also in this list. We click the percent linear float, and right now we can use this variable, which will automatically update when you move the wheel hub, in an expression in the function of the susp anchor. So 0.5 is our standard position. We want to deviate from that, so we're going to add a value to that. That value will be P1 minus 0.5, which is how much P1, or wheel hub's position, will deviate from 0.5. So you will see how much the wheel hub has been moved from its center point. We'll multiply that with the absolute value of P1 minus 0.5, which is the same actually. So we're actually linking it to a quadratic function. We're powering this to 2, but we're using this absolute value to prevent our power from stripping our sign of the result of this power. That means if you power -2 to the power of 2, you will get 4, while we want to keep that at -4 if there is a minus in the equation. And we're going to multiply this by 2 to prevent the number of from getting smaller. Right, so we click evaluate, and you see the position of this dummy hasn't changed. You can freely select objects and test, and right now we see our spring function is nicely working. Notice how small movements affect this suspenker little, and big movements, whoop, push it up very fast. So that's it for our float expression. We've just created this nicely working spring setup here. What we need to do now is duplicate it to all 3 other wheels. To do that, we select the 2 lines, move them as copies, align them to either of these objects. Make sure to turn off Z position so both objects stay in their own Z position. We select them and we will rename these to rear right and rear right. Now we don't need to type the expression again entirely. We're going to go into the motion panel of the one we just worked with, go to properties again, select the expression, hit Ctrl C, close it, go to the new susbanker, and we need to add the path constraint first. So constraints, path constraint, link it to this one, delete the keys, set it to 50%. Now select the wheel hub, animation constraints, path constraint, link it to the second one, delete the keys, set it to 50, and we can get started on the expression. Scroll up, path constraint, set the percentage to a float expression instead of a linear float. Paste the expression, create P1 again, and assign it to a new controller, which won't be the rear left wheel, but the rear right wheel hub. Open this one, you can see the path constraint is in there, select the percent, hit OK, evaluate, just test this to make sure you didn't select the wrong one. That's working, close it. Right, so we've set up the suspension for the rear axle. We need to do the same thing for the front. Select these 2 lines, move them, align them, set up the path constraints again. It's annoying that Max does this animation thing by itself, but there's no easy way around it. Set it to 50. We select the wheel hub, not the steering hub, the wheel hub, since this is the parent of all the other 2. Animation constraints, path constraint, click it, delete those, set it to 50. Select the suspension anchor again, fold open the path constraint so you can change the percent to a float expression. Paste the expression again, create P1, and we're going to have to assign that to the front right wheel hub. Wheel hub FR, path constraint percent OK, evaluate, testing, that works, close. Last one. Might have forgotten the names here. Yeah, this one has to be front right, and this one has to be front right as well. Okay, so let's rename these 2. front left, and front left. Setting up path constraints again, the boring job. Oops, animation constraint, path constraints. Delete those. 50. Animation constraints, path constraint. Select the path. Delete the keys. Set the percentage back to 50. Okay. Almost there. Go to the susp anchors percentage. Change it to a float expression. Create P1 and link that one to dummy wheel hub front left. Path constraint percentage. Okay, evaluate. Always make sure things are working before you move on. Right, so now we have all our suspension set up. What we want to do is create a sort of axle linkage between the two that will simulate the roll of the specific axles. To do that, we are going to have to create a new component. Go to Objects, Line. You want to create it between the two wheels. Just doing this in top view, estimating things as I go. Back to perspective. In the line, I go into vertex mode, select one of the vertexes, and then use the Align tool to align it with the susp anchor. Z position. Okay. It's interesting how you could use the Align tool on vertexes also. It's quite powerful to do things this way. You never have to bother about estimating positions. Okay, so we've aligned those two. Now notice when we go to the hierarchy panel and select Effect Pivot Only, the pivot is still in the original position. We want to move this one to either one of these susp anchor dummies. I'm going to choose the left one. While moving the pivot, we use the Align tool, click the rear left susp anchor, and hit OK. So this line isn't very obvious as a single rendered line, so we're going to change that and enable it in viewport. Make it a little bit fatter. There we go. So now we have this line. We want it to move along. One end has to move along with the left dummy. The other end has to move along with the right dummy. What we're going to do is use a new type of constraint for that. That is animation constraints, position constraint. We'll constrain this object to the dummy you've aligned its pivot to. So right now, if we move this one up and down, the axle is nicely moving along. Now we still want this point to be linked to the other dummy. So if it doesn't move, it still has to point that way. Time to use another type of constraint. It's animation constraints, look at constraint. Select the right dummy. You'll notice it totally jumps out of place. This is not what we want to use it for. So we go into the motion tab, go down, make sure we're in the rotation list. Should be if you just use the look at constraint. And then right here we can select the look at axis. It's set to X by default. If we click Y, it jumps into the right position. Possibly it could also be flipped around. It could be this. It could be the Z-axis. It could be flipped. You just have to play with these look at axes a little bit to make sure things are aligned correctly. Right, so now if you move this one, there's a nice connection between the two susp anchors. We need to do the same thing for the front axle. I'm just going to create a new line for that. Since this one, if you duplicate it, still has the same constraints, it's easier to just create a new one. Click, click, right mouse button to exit line creation mode. And go into the modifier tab, select vertexes, align it with the left dummy, align the other vertex with the right dummy, hit OK, hierarchy panel, effect pivot only, and align that one with the left susp anchor. Hit OK. Right, so This one's got another color than the rear one. That's fine. We want it to be a different color. Okay, we'll do the same thing again now. Animation, constraints, position constraint, constraint to the right dummy, animation, constraints, look at constraint, and constrain that one to the right dummy. Look at axis Y fixes things. Once again, in your case this might be different. You might have to experiment a little bit with these values and see what works for you. Okay, so we have built the two axles. Now we want another axle to connect these two together, so we can get, apart from body roll, body pitch, where the body's front and back moves up and down depending on what you do with the wheel positions. For that we will need to create a new dummy, but another thing you can't forget is renaming these to line, axle, front. And this one, line, axle, rear. Always make sure to name your components correctly, because as you noticed when using the expressions, it's hard to find objects you haven't named correctly. So time to create another line. I'm going to do this from the top view again. In the middle on the front one, in the middle on the rear one. I hold shift to make sure this one goes in a straight line. And click OK. Right, I'm going to leave that one there. It's going to be hard to align this one since our pivot is there. We need to create some more dummies for that. Dummy, not too small. Dummy, front axle, center. Click align, align it to this axis, but turn off Y position alignment, since we want the Y position, which is now -6, to be 0. I do that by right clicking these spinner buttons. Always resets it to 0. Shift move this as a copy, and we'll call this one dummy rear axle center. Align it to this axis, and Y position is still off, so we're safe. Right. Now, same trick all over. Modifier, select vertex, align, hit OK, select next vertex, align. I actually forgot the Y position for this one. Should be good now. Okay. This line will be called line axle body. Always use capitals. Okay. I guess you can imagine the same thing we'll be doing as we've been doing all along. We'll create another position constraint with another look at. That means our pivot has to be centered and aligned to the rear dummy. There we go. Okay. Animation constraints, position constraint to the rear axle center, and now animation constraints, look at constraint to the front axle center. It's flipped around. I have to go back to the motion tab, and the look at axis has to be flipped. There you go, it's been fixed. You see how this is very much dependent on what view you create things on, what you want to align to what. Really, there is no solid rule for that, you just have to experiment. So if we now move these up and down, you see the center isn't moving yet. To have it moving along and rotating with the axles, we need to use the link tool again and link the axle centers to their respective axles. And here we go. And there you go. This is working nicely. We've pretty much built our suspension setup now. What we want to do now is create a dummy in the center that takes on all these transformations dictated by the wheels and transfers them onto our body mesh. Create another dummy for that. Let's make this one big since it's an important one. We'll call it dummy body susp for suspension. Hit the align tool again and align it to the axle body, but we'll align it to the center instead of the pivot point. Now this is fairly high for our car, so I'm going to be moving this down a little bit. We might have to change that a little bit later, but it doesn't matter at the moment. And of course we need to link this to our center axle, our body axle, and you will see if we move it now, the pitch is nicely adjusting. But there's a problem. It's not using our roll from the axles. What we're going to use for that is another type of constraint. It's called an orientation constraint. Hit this one and select the rear axle. Nothing's changed, that's normal. But we actually want it to not only use orientation from the front axle, we want it to average between the front and the rear axle's orientation. You can actually add more targets to a constraint so that the actual object averages its constraint between those two. So we'll add another target and choose the front axle. Right, I've selected one too many. You need to hit right mouse button to go out of adding targets. Select this wheel, move it up and down, and you see the roll is nicely being used, but the problem is now the pitch is being ignored again. We can fix this by going into the motion panel again, and the problem is it's using this roll in world mode. We actually needed to apply it locally on top of the inherited orientation from the body axle. We do this by changing the transform rule to local. So we're going to move these up and down, and there you go. It's nicely pitching and rolling as it should. Okay, we want to test this, so we are going to unhide our mesh layer, use our link tool. It's one of the great things about mechanical rigging. You don't have to skin. You can just link objects together, since they pretty much 99% of the time they form as one piece. Hit the body, and this is going to be tricky since it disappears. Link it to the dummy. There we go. Okay. At the same time, we can already link our wheels to our wheel dummies. It's the same trick over again. This one's being hard to find. I have to try again. There we go. Same thing here. And this is tough to do. Linked it to the wrong one actually. You can unlink this. Actually, there's a trick for this. You hit Alt X to go into X-ray mode, so you can actually see through the object. Now you can perfectly see. There we go. We've aligned it. You probably have some trouble with this also. Hit Alt X again to go out of X-ray mode, and we can start testing this setup. Select one of the wheel hubs, move it up and down, and you can see how the car body is nicely reacting to our suspension changes. If we would move two wheels up at the same time, now this is hard to select. What you can do to make this easier is actually freeze the car body, and then you can just go and select controllers like you want. This moves both of them up. It's working nicely. Yeah, this is what we need. Okay, this is working. Now I'm going to unfreeze this again. There's one thing missing from our car's body pitch and roll system. If a car is cornering, it actually rolls over to one side depending on what direction it's cornering in. Same as braking, a car pitches forward or pitches backwards during heavy acceleration. We have no way of controlling that. We're going to build a system to control that as well. Start off by hiding the mesh again and creating some new components for that. Create this dummy, smaller than the center one. I call this one dummy body momentum. We will align that one to this one, and of course link it so it is transferred. Now we want this dummy to change its orientation depending on another dummy on top to which it will be pointing. You might be thinking we're going to use a look at for that, but no, we won't be, since a look at is not the best solution in this case. We're going to need to create another dummy first. Dummy momentum controller. Let's not forget my underscore. Align that one to this one again. We're going to move it up since I was talking about a controller on top of it. There we go. And we will link this one to the body momentum. Right, so you notice these move along nicely if we change the wheels positions. Okay, now we're going to use something special here. We're going to use an IK solver. IK stands for inverse kinematics, and an inverse kinematic is something that can only be created between a parent and his children. We choose an HI solver and hit the top one. It doesn't matter in which direction you do this. You can select the top one and then the bottom one. It'll always end up the same since it's dependent on the hierarchy between objects. Now it's also created this new blue point which is called IK chain 01. I'm going to rename that to IK handle momentum right away. And instead of moving this dummy, which you will notice is impossible and behaves very strangely, you have to move this handle instead, and you see nicely pointing towards that handle. So let's test the system out. We're going to unhide our mesh, and instead of linking it to the susp dummy, we're going to link the body to the momentum. There we go. Select the handle, and immediately it's obvious that even the slightest movement pushes the car into extremes. You want to make this a lot easier to use, so we want to dampen the movements from the IK handle a lot more. I'm going to build a special system for this again, so more components, hide the mesh, and create a new dummy. Make it slightly bigger than this top one. Call it dummy momentum target. Make sure there are no typos here. And of course, use our trusty align tool to get them in the same position. This one will be linked to the body susp, since we also want it to rotate along with our suspension. And we want to link this one to our body susp as well, the handle. Right, so same thing as we did with the orientation constraint, we can also average between two positions with multiple position targets. I'm going to select this handle, use animation constraints position constraint, and constrain it to the target first, and then add a position target, which is the momentum controller. Right, now if we move this one, you see the target is nicely averaging its positions between. Now it's still moving a little bit too extreme, so what we can do to fix that is change the weighting of the targets. We want it to move a lot less towards the target and stick more to its center, which is the momentum controller. For that reason, we change the weighting for the target into 10 and for the controller into 90. if we move the target now, you can see it's responding very, very slightly. Let's unhide our mesh to test this system again. Yes, this is exactly what we need. Big movements translate into the sort of stuff an animator will want to do with our mesh. Same with body roll. That's also correct. Now let's see what happens when we move these. Nice. This is also working. So we have two systems on top of each other for two different types of body pitch and roll. I'm going to hide this mesh again, because at the moment we have a little problem. Our car is of course going to be moving around in our scene, rotating and everything, and for that reason you want to be able to move a rig. Now, moving works, but you see some strange things happening here. That's because these path constraints are acting strangely, and the same thing with rotating. You see the rig is totally going berserk. What we need for that is one single object to which all these parts, all parents at least, are linked to, that we can use to control the mesh. To create some sort of intermediate root component for that, I will use a circle, create it about there. Give it a nice and obvious color, yellow. And I want to align it to this dummy, but not on the Z position. I want it to stay on the ground. Reason for that is, I'm going to give this rig some functionality to do drifts and power slides. Of course, that's always cool in an animation. And for a drift or a power slide, the rig has to rotate around the center of the front axle, since the rear end breaks out and rotates. So that's what this route is going to serve us for. Okay, so we're going to call this one slide pivot. And start linking our components to that. We're going to select these lines, since, as we noticed, the wheels are constrained to these lines. And there we go. Right, let's see what this does. Okay, if we rotate, we see a problem. Our dummies are not rotating how they should. That's because these independent dummies are only using the position from their line to which they are constrained. You actually want to be parenting them to this as well. Do the same thing with the rear axle. Zoom in some more if selecting is hard. And link them. There we go. Let's see, moving works fine, as you can see. That's not a problem at all. Everything in the rig seems to stay in order. Let's see about rotating. Yeah, the wheels are fine, but there's something funny going on with that center one. Let's see, unhide this mesh, rotate it again. And you see our mesh is rotating twice as fast as our actual rig. The reason for that is, let's hide the mesh again. This center dummy is linked to this axle, but is also orientation constrained to these two. Since both of them are rotating, the rotation is being applied twice to the center dummy. So we need to disable rotation inheritance from one of the components that is dictating the dummy body's susps orientation. For that reason, we go to the hierarchy panel and go to link info. This is actually a tricky one if you don't know where to look. It's inheriting rotation over the z-axis, so we need to disable that. Once that is disabled, we select this one and rotate it, and we see everything is fine. Let's test other rotations. This is also working fine. And what about pitching it? That also seems to be working fine. So we're going to unhide the mesh, pitch it forward and backward. That looks correct. I'm going to roll it, and if we rotate it like this, that also seems to be correct. So we've built our rig for the first part, and we've linked it to a single controller. How we're going to continue this is for the next part of the tutorial, so stay tuned.